In this video, we're going to look at multiplying and dividing radicals. The thing to remember when we are multiplying and dividing is we can multiply the coefficients, keep them outside of the radical, and then we multiply the like radicands, meaning they have the same index, and keep them inside the radical. So we're going to do all of our multiplying first, and then we're going to simplify. Okay, so saying that, when you look at number one, hopefully you can see the square root of 25 is 5. So at this point, there's no reason to multiply these and then go backwards and simplify, because you could and you get the same answer, but it's kind of redundant. So the square root of 25 is 5. And we're just going to multiply that by root 5, and that gives us our final answer. It's a very simple version of this kind of problem. So make sure you're looking for those perfect squares and perfect cubes, because it does make it a little easier to simplify in the long run. Okay, for the second one, we're going to multiply our coefficients. So I'm looking at these, and you can go ahead and multiply your coefficients and multiply your radicands inside. If you can see that you can factor it, you can go ahead and factor out and then continue with the multiplication. It doesn't matter which method you use, as long as you're doing it correctly. You'll end up with the right answer. So I'm going to stick to these steps up here just to keep it simple. But if you pull a perfect square out and then do your steps, that's okay. Okay, so I'm going to put some parentheses here just because the multiplication and a negative sign that goes with the 2 gets a little confusing. So to help myself visualize, I'm going to put my quantities in parentheses. Now I can see I'm taking 3 times a negative 2, which is a negative 6. And then inside, they're both square roots, so I can multiply them. 10 times 18 is 180. Now I need to break down the 180 so I can take the square root of it. So it is going to be 9 times 20. And I know the square root of 9 is 3. So I'm done with that side. 20 has a perfect square also. It's going to be 4. So 4 times 5. I know that 2 squared is going to equal 4 times 5, which is my that will be left in the radical. And so I'm going to take negative 6 times 3, because I pulled out a 3 squared, times 2 times my square root of 5. And then I'm just going to multiply my coefficients. So a negative 6 times 3 is negative 18, times 2 is a negative 36, square root of 5. Okay, on the next one, we're going to go through and do the same thing. So 2 times 5, and you can go ahead and put your parentheses in here if it helps you see it. 2 times 5 is 10, and we have 2 cubed roots, so we can go ahead and multiply those. 9 times 24 is going to be, or a negative 24 is going to be a negative 216. And then we're going to divide this out. And so I'm looking for cubed roots, and I can see that 16 is a multiple of 8, and 8 is 2 cubed. Okay, and so then I can just figure this out. This is going to be 8 times 2 would be 16, and then 56 would be 7. And I also know 27 is 3 cubed, so that worked out nicely. I have 2 cubed and 3 cubed. So this is going to be 10 times, and then I've got to pull out my negative 1 because it's an odd index number, times 2 times 3. So when I multiply all of that out, I get negative 60. Okay, so same steps over and over. On this one, you'll see that this is 2 binomials. These are actually conjugates. So the first term is the same, and the second term is the same. The only thing that is different is one is plus and one is minus. So if you remember from algebra, if we do a plus b times a minus b, if we did the FOIL, the first 2 terms are going to be a squared, but then we're going to have a positive AB on the inside and a negative AB on the outside, and those are going to cancel. They'll add up to be 0. And then a plus b times a minus b is going to be minus b squared. Okay, so we can square this first term. So 6 square root of 3 squared minus, and then we square the second term, which is 2 square root of 3. And now we'll simplify. So 6 squared is 36, and then square root of 3 times the square root of 3 is going to be 3. Remember, the 2 for the square root index and the 2 exponent are going to cancel each other out. And we'll do the same thing over here. 2 squared is 4, and then root 3 squared is 3. 36 times 3 is 108, minus 12 will give us a 96. Okay. When we are dividing, we're going to follow the division rules for exponents. So remember, when you divide, you have to subtract the exponents. And again, we have to keep our coefficients outside and our radicands inside. If they are the same, if they're like terms, meaning they have the same index number, then we can combine the like terms. So in this first one, I'm going to write this as a square root of just the x's, which is going to be x cubed over x squared. And then we're going to multiply that by the y's. We're going to group the y's together. So y to the 9th over y to the 5th. And now when we simplify, all we have to do is subtract. So 3 minus 2 is 1. So this is going to leave the square root of x to the first, which we won't write that. We'll leave that there. Times, and then 9 minus 5 is 4. So we're going to have the square root of y to the 4th. Now we know that if the index is 2 and the exponent is 4, we can divide just like we did in the last lesson. And so the square root of y to the 4th is going to be y squared. And then we're going to keep our square root of x. So notice that the terms that do not have radicals are going to come first. They're typically going to come in alphabetical order, and they're going to come in, and then there'll be the radicals inside. Okay, for number 6, so we have the 4th root of 32w over 81. And when I'm looking at this 4th root, I'm looking for numbers that I can pull out. So I'm looking for the perfect 4th roots, which means multiples of 4. So if we look at 32 and we break that down, 42, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So hopefully you can start using these and you get them memorized. So we have 2 to the 4th is 16, and then 16 times 2 is 32. And then we'll do the same thing with 81, okay? So 3 times 3 is 9, times 3 is 27, times 3 is 81. So 81 actually breaks down into 3 to the 4th with no extras. Okay, so we're going to go ahead and write these out. I'm going to rewrite my terms so that we have this top, the numerator is 32w. So this is actually going to be the 4th root of 2 to the 4th. So I'm pulling out that 16, and then I still have the 4th root of 2w because I want to make sure I get all the way up to that 32w. And then in the denominator, we have 81, which is the 4th root of 3 to the 4th. And now we can start simplifying. So the 4th root of 2 to the 4th is going to be 2. And the 4th root of 2w is going to stay the same. And then the 4th root of 3 to the 4th is just 3. Now, if 2/3, it cannot be simplified, and so we can stop there. But if it were a fraction that could be reduced, you would want to do that, simplify your coefficients. Okay, for these problems, notice I have a radical in the denominator. And so I can't simplify up here because square root of 8 and square root of 2 are not like terms. So I'm going to rationalize the denominator to get rid of that square root of 2. So I'm going to distribute the square root of 2. So that gives me the square root of 16 minus 2, because remember root 2 times root 2 is just 2. And then on the bottom, we'll have 2 again. Okay, and then I know that the square root of 16 is 4. Whoops, I'll come down here. So 4 minus 2 over 2. This is going to be 2 divided by 2, which just gives me 1. Okay, same thing for number 8, but notice there's an addition sign. So I can't just multiply by the square root of 2, because when I distribute that, I would still have a square root in my denominator from the 4. So instead, I'm going to multiply by the conjugate. So I'm going to multiply by 4 minus root 2. If this had a minus in it, then I'd have to use the plus version. And whatever we do in the denominator, we also have to do in the numerator. So for the numerator, I'm just going to distribute my 4. So I get 16 minus 4 times the square root of 2. In the denominator, I'm going to use that a squared minus b squared shortcut. So 4 times 4 is 16. And then root 2 times root 2 is 2. Whoops. And I know that I have 16 minus 2 is 14. And I can factor out a 4 in the numerator. So I get 4 times the quantity, 4 minus root 2. And in the denominator, I can factor out, well, I can just leave it 14, but I'm going to divide both of these by 2. And then I'll get my final answer of 8 minus 2 times the square root of 2 divided by 7. Okay, there's multiplying and dividing with radicals. So you can go ahead and try the check your understanding, and the link will be